So hello guys and welcome back to the day 3 of our data science workshop. Yesterday you learned how to understand the data. But today you are going to teach a machine how to think. So this is our theme, from analysis to prediction. We are no longer just looking for at the data. We are looking to build something that can predict outcomes. So let's quickly understand this shift. Yesterday, you cleaned the data, created graphs, and found some patterns as well. So these are few patterns that we found yesterday using the graphs and all the charts, all the historical patterns, histograms. Then we looked at scatter plots. The notebook had been added or updated with few more graphs as well. There was a 3D graph that I draw. There was a pie chart as well. But today we take a next step. We will learn machine learning and build a prediction model that makes particular forecasts. So yesterday you understood the past and today you build an intelligent system. Now what exactly is machine learning? Traditionally we used to write rules, input, then it went through rules and then we got a certain output. So this was a traditional system. But in machine learning what happens is that we don't write the rules. We give the data and the correct answers and the machine learns to identify the rules itself. So we teach the machine how to find these patterns, how to understand them, how to learn about them. And this is already happening around you. You can find this through your YouTube recommendations, Google Maps editors, then spam detections in your Gmails, or let's say crop prediction that we are going to find it right now. Machine learning is the invisible engine that powers our daily life. There are three types of machine learnings. First of all, there is an supervised machine learning, then there is unsupervised machine learning, and last is the reinforcement machine learning. But today we are going to focus only on supervised machine learning. Why? Because here we already know the answers. We are just going to predict it in the future. And look at this. We give the input features. First of all, it is temperature, then there is moisture, then humidity, and the nitrogen content in the soil. These all parameters will go through machine learning model and they will predict us the fertilizer name as we get the outputs. The model learns how to map these things, and this is exactly what we will be building today as well. So now here is a real world problem. Can we predict the correct crop fertilizer based on the environmental data? This is not just coding. This is about solving real engineering problems by understanding the methods that are already being used in the Indian subcontinent. Now moving on to ML pipeline. So this is very important. This is the machine learning pipeline. So first of all, we load the data into our dataset or the Google Colab notebook that we will be using, the engine. Then we will prepare the data. We will split the data, the half of which will be training the data, and the other half, since the machine learns its model, the other half, the trained data will be then put to test, and then we will move on with the prediction of the model. This is the standard workflow followed in all the industry related to machine learning. Now the question arises, why do we exactly need to split the data? That is 80% in training data, 20% in testing data. So the answer is simple. If we don't split the data, the model will just memorize everything. And memorization is not intelligence. While you are also giving your exams, everything that you have been memorizing does not appear in the exam as it is. You learn those things and put it in your own words. Your actions are what matters the most in the examinations as well. Now, here comes the brain of the system, that is the model. Today we use logistic regression. It is simple, fast and perfect for the beginners. Think of it as like the function that changes or separates the categories in two halves. Now here is a danger as well, that is the overfitting. Model memorizes the data instead of learning patterns. This fundamental approach is known as overfitting. We don't want memorization as we have already talked about it earlier. We want a generalized stream. We want to create the model that learns based on the data that we have provided. So now the next thing is, how do we check the performance of the model that we have created? We use the terms accuracy, and accuracy is what we get from the confusion matrix. So exactly, we don't just ask, is it correct or is it not? We ask, where is it wrong and why? So this is the confusion matrix that is being provided. It includes four variables. The true positives, which means it is all correct. Then there are false positive. That means literally it was correct, but it has been devised wrong. Then there are false negatives, in which the same thing happens but in opposite way. And there are true negatives. It was wrong and it was predicted wrong already. Okay, now the exciting part. We give the data. We give new data, the temperature 28, for humidity 45 degrees, and then the model will predict its own fertilizer, what it is going to use. This is where our system becomes useful in our real life. Then now we combine all these things. So first of all, we take the raw data from the model or the data set, then we split it, train it and test it. Then we form a logistic regression engine. We put it to test in the confusion matrix, and from that we get live prediction analysis system. So remember guys, this is not just code. This is a complete engineering system. Now remember this as well. Yesterday you understood the data. Today you teach the machine how to think. Now enough of theory lectures. Let's actually build this model. So open your Google Colab and we will meet you right there. Today we create our first machine learning system. So alright friends, today we come up with the most exciting part of the day 3. We are not just learning about machine learning, we are actually going to build a prediction system based on it. And by the end of this session, you will have working model that can predict fertilizer based on the real world data. So let's get started step by step. So first of all, the thing that we do is importing the libraries. As we discussed in the previous day, libraries are the most crucial part of any machine learning system, because instead of writing the whole code, libraries are made or available so that we can just import these libraries and take all the functions that are present in the libraries instead of just going on writing a function word by word. Okay, so let's start by importing the libraries. I'll write a subheading which is importing libraries. Okay, importing libraries, and I'll start writing a code. So I don't want this particular cell on the top, I'll just delete it, and here I'm going to write about few libraries. So first library that I need is import pandas as pd. The pandas library is used to like fetch the data details from a particular data file that we want. Then we are going to import a library known as numpy. Okay, numpy as NP. So NumPy is the library that is used for mathematical analysis. So instead of writing all the codes related to finding a square root or multiplying or dividing the numbers, we'll just import library of NumPy and we'll just take in the functions and use them as we want to use them. Then we will import few libraries such as matplotlib and seaborn, which are used to draw graphs or predict some visualized effect. So import matplotlib dot pyplot as pld. Okay, and then it should not be this particular square brackets, I'll remove that, and import seaborn, caborn as sns. Okay, we will also be required to import few libraries known as Scikit-learn. So these are few libraries, Scikit-learn libraries. These are the ones that actually make machine learning possible. Okay, so there are few libraries. I'll just be typing the names, you go through them. Okay, from Scikit-learn dot pre-processing import label encoder. Okay, so from this scikit-learn pre-processing library, I am going to import a particular function or library that is known as label encoder. Then from scikit-learn dot model underscore selection import train underscore test split. So this library is going to split our data set into two different parts, the training data set and the testing data set randomly. Okay, then from sklearn dot linear model. So this is used to perform the linear regression, import regression, and then from sklearn dot metrics, import, we are going to import the codes for accuracy score, confusion matrix and classification report. So accuracy score, then confusion matrix and classification report. Okay, so I'll run this particular cell block and it is going to give us this particular tick. So since there is this tick, that means the code has successfully been executed. Now the next thing that we do is to load our dataset. So how do we load our dataset? I am going to click on this particular icon here, the file icon, as we can see here, and on clicking it, it is going to open this particular tab, and in this tab below sample data we will get our file. Okay, so first of all we have to go to the place where we have stored our file. For me it was in file explorer. I am going to drag it here. Okay, and after dragging, it is going to tell me warning to ensure that the file is saved elsewhere, because once we close this particular session the data is going to be lost. Okay, now I am going to copy its path. and I am going to write here load data set. Okay, and after this what I am going to do is I am going to define the data file df. So I am going to define the data file using pandas library pd.read_csv. Okay, read_csv, and in this round brackets and a inverted comma, single inverted, I'm going to paste my file's location. So once this location has been pasted, I am going to write here df. So it is going to print me the complete data file. So I'm going to run this command. It has been mounted, and as we can see here, this is the yesterday's file or yesterday's data set that we had worked on. So there is temperature, humidity, soil type, crop type, nitrogen, potassium, phosphorus and fertilizer name. Okay, and there are a total of 8,000 rows. There are 8,000 rows divided over like 9 columns. Okay, so ranging from 0 to 799, including 0 it becomes but obvious 8,000. Okay, now we are going to start our real code. And look at this, like there is temperature, humidity and different types of combinations. So this is not just a random data, this is a real agricultural system based on which we are going to check its structure and all. First of all, we will go on and check its structure. So to check the structure, we write this code df.info and round brackets and control enter to run it. So this is the info that we get, 8,000 entries, 0 to 7,999. So there are these different types of columns. Okay, there are few data types like float 64, which means they are in decimals. There are objects, which means they are like strings of data. Then there are int 64, which means they are integers, proper integers. Okay, then as we can see, there are no null values. So everything here is non-null. If there had been null values, we would have eliminated that particular row. So this is perfect data set for building our first ML model. We don't need to clean it completely. It has been provided, clean data set has been provided to us. Now we move on to a part which is known as encoding. So I'll be writing here encoding and enter to get us to the new code. Okay, so here is an important step. So machine learning performs models that cannot understand text. They only understand the numbers. So we convert all these categories into the numerical forms. Okay, so for this what we are going to use is the label encoder. The first function in sklearn library that we imported, that was the label encoder. So we are going to encode that particular data. So we are going to type here label encoder, that is LE underscore soil, equals to label encoder function. Then we are also going to do it the same way for crop and for fertilizer. Okay, so here I am going to write CROP and FERT. Now we apply encoding. Okay, DF in square brackets, I'm going to write soil type is equal to LE underscore soil dot fit underscore transform, and in this function df in square brackets I'm going to write about soil type. Right, so this has to be carried out for all three, that is crop and for fertilizers as well, for crop and for fertilizers. So here it will be crop type. Instead of soil dot fit I'll be writing crop dot fit. Okay, and fertilizer name, and here instead of soil it is going to be lay underscore fert, and okay, and here instead of soil type it is again going to be fertilizer name. We are going to run it and it has successfully been executed. Now all the data that we can see in here are numeric. So these object data, the soil type, the crop type and the fertilizer name, all these data have been converted into the numerical understanding so that the machine can understand it. Now we move on to the next thing, that is features and target. We defined inputs and the outputs that we want. Okay, so we are going to add this text known as feature and targets, FEATURE, and targets, and in this I'll be adding a code file in which I am going to define the x, which is equal to df, and in this df I am going to add a square bracket, and in particular square bracket I am going to add another square bracket which will have temperature, then I'll move on with comma. Here I'll have humidity, then I'll move on with moisture, then I'll move on with soil type, then I'll move on with crop type, then after crop type I have nitrogen, then I have phosphorus, and I have potassium. Okay, so phosphorus was after potassium. Okay, so this is about the x-axis. Now we will be moving to y, which is the answer output that we want to find. So y equals to df, and we are going to predict just about fertilizer name. Okay, control and enter. So there has been some problem. Okay, so I don't want this particular semi inverted comma and control enter again. It is giving me some. Okay, there are few words that I have mispronounced, so I'll have to check over here. I'll copy the name of temperature, paste it here. Then we have, what do we have? Crop type and phosphorus. Okay, crop type, there should be a space bar between both of them. Okay, and for phosphorus, control C, I'll be here, and control V, excuse, and control enter. So this particular code block has successfully run completely, and now think of this is like X is the input and Y is what we get as the output. So we are teaching the model, given this particular values of X, you have to predict the Y. Okay, so this is what the machine understands from this. Now comes the most important step, which is training and testing. Okay, so for that we will need to add a new subblock, which is train test split. And in this I'll be adding a code which is about X. We will have to X train, X test, and we will have to also specify Y train and Y test. Okay, so X underscore train, X train, then we have X underscore test, we will have Y underscore train, and we will have Y underscore test equals to train underscore test underscore split. So to perform this particular action, we had imported this particular library, train test split. We are going to use it here now. Okay, so as soon as we are introducing new libraries, I'll also be specifying what libraries we imported and their importance in our code as well. So this is the most important part. Okay, now we are going to specify this particular function in which X comma Y comma the test size is going to be 0.2. That means 20% of the data will be divided for testing purposes and the 80% of data will be divided for the training purposes, and the random set is set to 42. So test underscore size is specified as 0.2, which is almost 20%, and random underscore state. So this specifies the randomness of our operations. Random state is specified to 42. Control enter. It is running the code. Okay, this has completed its execution. Why we need to do this? So to test if the model actually learned everything or just memorized, this is the function of randomness that we need to define. Now we also need to check if this has like completely split the training and testing data sets. So for this we need to print their shapes or sizes as well. Okay, so we will check if it really has done its part. So print, in this print I'll be writing, let's say, training size, and for this I'll be giving just X. So X underscore train dot shape. Okay, and then print, in brackets we'll have to give this as testing size. Okay, and for this we will need to write X underscore test dot shape. This is going to give us the size. Control enter, and as we can see here, training size is 6400 and testing size is 1600. We can add both of these to find if the total comes around like 8000. 6 plus 1 which is 8, 8000 total columns. The rows will be divided, and there are total 8 columns that we have given for training purpose, and there is one column which is fertilizer name that we have given for output purpose. So 8 columns for input and one column for output. We can also check it like this. So instead of x, we will move on with y. Here as well y, and control enter to get, okay, 64,000, and this nothingness means 1. Okay, there is only one column for which we have to find our output. Okay, so I'll again go back with x and control enter, 6400 and 1600. Okay, now comes the next part, which is training the model. How do we train the model? For this, I'll be adding a text here. I'll be specifying the text, which is train. Okay, and in the train I'll be writing model. So what kind of model are we using? Model equals to logistic regression with maximum iterations of maximum iteration of 1000. So the code is going to run 1000 times to find the value of that particular best fit line, and then we are going to find the best fitting model dot fit, and in this I'll specify x underscore train comma y underscore train. Okay, now something important is happening. So the model will learn the particular patterns. This is trying to understand what kinds of combination of features are leading to the output, that is a fertilizer. Okay, the training is happening right now. So we will control enter. The model is running right now. So the model has completely run, and we are getting maximum iterations of 1000. So the model has completely been run in almost like 2 seconds, 1 second or 2 seconds. Now the main part is to predict the outcome, to test it. So this particular thing has happened. Now I am going to add a new text file which is about predict. Okay, so in predict I'll be specifying y underscore predict which is equal to model dot predict, and in bracket I'm going to write x underscore test. Okay, it is going to predict, and it has predicted already for all the inputs. Okay, but on completely new kind of data, not on the data that it has seen, but on the new kind of data. Okay, now begins the most important part, which is the evaluation of this particular matrix. Okay, now we will begin with evaluation. Evaluation. Now we will be beginning with the most important part, which is about evaluation, and on what basis are we evaluating our model, or how good is our model. So to find how good our model is, we need to define the accuracy. How do we define accuracy? So print accuracy. So print accuracy, as there will be a comma, and accuracy underscore score, in which I'll be specifying y underscore test comma y underscore prediction. Okay, and control enter. Okay, there has been instead of prediction I'll have predict here. Okay, so this becomes clearer. So there is accuracy of 0.14185. So yes, let's look at this accuracy. Not bad for our first model. Okay, now we will be moving on with the continuation part, which is the classification report. Okay, now we will define the classification report. Print, in brackets I'll be writing classification report as classification report as print about creation underscore report uh, now classification report over y underscore test and y underscore pred. This is going to give us all kinds of classification report, the precision, recall, F1 score, and the support vector. So the accuracy that we have got is 0.14%. So don't worry too much right now. Just understand this gives the detailed performance. Now let's visualize the errors. Okay, to visualize the errors, we are going to perform the confusion matrix, the one that we predicted in the last lab as well. So for that, I am going to write here confusion matrix, which is equal to confusion matrix that is played over y underscore test and y underscore predicted. Okay. Now plt dot figure with figure size fixed size which is equal to 8 comma 5, let's say 8 comma 5. Now we will also add SNS heat map cbor dot heat map, in which I'll be adding a confusion matrix, then annotation to be true, then fmt to be d, and cmap equals to, in blue colors, blues. Okay, then I'll be plotting plt dot show. Control enter. It is going to provide me with the confusion matrix. So this is the confusion matrix that we have predicted. Now each box shows correct versus incorrect predictions, as we can see, ranging from 0 to 6 in the x-axis and 0 to 6 on the y-axis. This tells us where the model is making the biggest mistakes as well. Now the most important thing is feature importance. We are now moving on with feature importance. So instead of calculating the feature importance, these are like most important factors. First of all, let us know what feature importance is. So I'll be writing here the subheading of feature importance. And I'll be adding a code here in which importance equals to pd dot data frame in which this and first of all feature feature is given or labeled as x dot columns. Okay, and then importance is labeled as np dot absolute values of model coefficients dot coefficients underscore dot mean in brackets axis equals to 0. Okay, and after this we are going to sort those values as well. Dot sort underscore values in the brackets we are going to write by importance by equals to importance in the value of ascending equals false, and then again we are going to like print those values. Okay, that there has been some mistake here. Okay, so here there should have been a closed function as well. Okay, and then we are going to write here about print feature importance. In print I am going to write about feature importance feature importance, in which it is going to specify to importance. It is going to specify to importance. So look at this particular thing. There are, okay, so there has been a bug. Module pandas had no reference to data frames. So yeah, instead of this data frame, I have to specify here capital F and control enter. So let's see. Yes, there are these different types of feature importance things that we have finally got. So we have soil type as the most important factor that we have at play. Then the least important factor, that is the moisture. So now we are going to look at the final step. So based on what we have learned until now, this is where the data science has become more powerful. We are not just predicting, we are understanding why these particular things are happening. And now comes the most last and the final step, that is giving our own inputs to predict the outcomes. Okay. So here I am going to write about real predictions. So I am adding text data, and here real predictions, and in real predictions I'll add a code file. In code file I'll be specifying some sample data frames, sample underscore df, in which pd dot data frame, data capital F, frame, and data frame. I am going to specify all these 6 kinds of things that we have, and for that we have first of all temperature to be 30 degrees Celsius, then 60 for, as we can see, 60 for humidity, then we will be having 40 as our moisture, then we'll having 2 as our soil type, then we have 3 as our crop type, then 20 as our nitrogen content, then we have 10 as our potassium, and for phosphorus let us take a value of 15. Okay, so these all are going to set in the indexes of, so 30 is going to be set in the index of 0, that is about temperature, then 60 in the place of moisture, sorry, in case of instead of humidity, which is 1 index, then 40 in place of moisture, then 2 in the place of this soil type, then 3 in the place of this 4 number index, that is crop type, then this 20 in the place of like nitrogen. Where is nitrogen? I can't see it. Yeah, here the nitrogen, then 10 in the place of potassium, and then the phosphorus. So we are also going to like predict from this. So write down the code for prediction, in which we are going to model.predict, and we are going to specify this particular variables, that is the sample underscore df. Okay, we are going to specify this particular sample data frames, and predicted underscore label, it is going to fetch that particular words. Okay, for example, if we are using urea, so if we have to use urea in our soil, then it is going to print that particular urea rather than getting us the previous number. Okay, so prediction label. So in this particular line of code, we specified that all these things have to be transformed into numbers. Now what we are doing, we are going downside up. We are going to get the number as output, and this particular line of code that we are writing right now, this is going to convert that number into that particular type of fertilizer. It's according fertilizer. Okay, now predict label equals le underscore fert, okay, dot inverse transform and bracket prediction. Whatever the prediction, the number that we are getting, it is going to print us that particular number. Okay, now we are going to get print in bracket, we are going to get predicted fertilizer, and space, okay, comma, predicted underscore label, and here it is 0. Okay, and okay, look at this. I'll be running the code and it will be predicting me the fertilizer that I need to use in the soil conditions, or in these particular conditions, the temperature, moisture, humidity, soil type, then there is nitrogen content, phosphorus content, potassium content. Control enter, and okay, it is giving me some error. Okay, the predicted fertilizer. This is the predicted fertilizer, that is 14 35 14. Okay, this is the predicted fertilizer that we need to use in the soil of this type of kind, 30 60 40. Okay, so let us see if this kind of fertilizer is present in the data file. Okay, so I'll be going in this file icon. I'll be opening this data sheet. This is the data sheet, and in fertilizer name, we can see there is like this 10 26. Okay, we'll be moving on with 14 35 14. Okay, there are these kinds of soil, these kinds of fertilizer 14 35 14. Okay, so it has not given us the random names, any random names. This kind of fertilizer is already present in the data. Okay, so that is the fertilizer that we need to use in our soil. So let's take a step back. We started with the raw data. We first of all converted into the numerical forms. So here we can see all the headings that we had given. So first of all, we imported all these libraries. So the name of libraries were first of all pandas, used for data understanding purposes. Then we had NumPy, which we used for numerical operations. We had Matplotlib and Seaborn, which we used for plotting the graphs. We also had Scikit-learn libraries, different kinds of Scikit-learn libraries, which were used for pre-processing, which was done by label encoder. We converted into the object or the strings into the numerical data forms. We had model selector to train and split the data. Then we took logistic regression model from this sklearn.linear model. Then for metrics or calculation of efficiency scores, we use these particular libraries of accuracy score, confusion matrix, and classification reports. Then we loaded our data. We understood what our data was, converted it in numbers using this encoding in this cell. We converted the objects or the strings into the numbers. Then we evaluated it. Then we also specified the features and targets actually. Then we split the data into few parts of 80% for training purpose, 20% for testing purposes. Then we also applied this regression model on our data. Okay, then we predicted our data. We also printed our accuracy, the classification report, and the confusion matrix as well. And then we moved on to feature importance. So we looked at what feature was important in determining our model. Then we also included our model prediction. So I wanted this particular thing to be like interactive, so you can change all these values 30 40 60 and all to get your own soil, to get your own type of fertilizer report as well. So this particularly is machine learning. This is what companies use in their real life systems. So tomorrow we improve this model, we try better algorithms and move closer to like real world applications. So logistic regression was just one kind of model that we worked upon, that we saw what it does. Tomorrow we will be moving on with the different kinds of model. Maybe there will be higher kinds of machine learning models. So stay tuned for tomorrow's practice as well. Until then, practice and experiment with this particular data set. Try to change the inputs, because now you are not just learning, you are building the real life intelligence. So that's it for today, guys. I hope you like this particular workshop of today, and I hope if you have liked, you will hit that like button, share it with your friends who are interested in data science and data visualization and analytics kinds of things. If you want to upgrade your careers, and if you want to change your paths, if you are from any like non-CS type of branches, you might have liked this course, but obvious, share it with your friends, subscribe to my channel first of all. And in this series I'll be bringing two more videos, or two more videos actually, for day 4 and day 5. So today we began with like intermediate studies of artificial intelligence. Tomorrow we will be improving our platform, and in the day 5 we will performing real life application, how to host it and all. You will be able to make a CV ready project. Okay, and yes, on this channel I'll be bringing you different kinds of videos based on like machine learning, or let's say computer intelligences, then electronics and electrical subsystems. All these kinds of videos are present on my channel, so please go and watch them out. Until then, have a good day, enjoy your day, adios.